What is computational neuroscience? Computational neuroscience is a field of study that combines neuroscience and computer science to understand how the brain works. Computational neuroscientists use mathematical models, computer simulations, and statistical analysis to study the neural basis of cognition and behavior. Computational neuroscientists have developed models of how the brain processes visual and auditory information, how it learns and remembers information, and how it makes decisions. One of the most important tools used by computational neuroscientists is the mathematical model. Once a mathematical model has been developed, it can be used to simulate the behavior of the brain under different conditions. Computer simulations allow scientists to experiment with different variables to see how they affect the behavior of the brain. This can be helpful for understanding how the brain works under normal conditions and for identifying the causes of neurological disorders. Statistical analysis can be used to identify patterns in the data and to test hypotheses about how the brain works. Computational neuroscience has a wide range of applications. For example, it is used to develop new treatments for neurological disorders such as Parkinson's disease and Alzheimer's disease. Create new brain-computer interfaces that allow people to control computers using their minds. Develop new artificial intelligence algorithms that are inspired by the way the brain works. Here are some specific examples about how computational neuroscience is being used to study the brain. Vision. This research is helping us to understand how we see the world and how vision problems such as color blindness and macular degeneration develop. Learning and memory. This research is helping us to understand how we learn new things and how memory problems such as Alzheimer's disease develop. Decision making. This research is helping us to understand how we make decisions in everyday life and how decision-making problems such as addiction and gambling develop. Challenges. Data collection. Computational neuroscientists need access to large data sets of brain activity data. This data can be collected using a large variety of methods such as fMRI, EEG, and MEG. Model development. Computational neuroscientists need to develop more accurate and comprehensive models of the brain. Model validation. Computational neuroscientists need to develop better ways to validate their models.